You know what? Let's just avoid going hotter than the eutectic temperature, and then we don't have to worry about any of the melting. Eutectic. E-U-T-E-C-T-I-C. Eutectic. You might say eutectic temperature, eutectic composition, eutectic point, eutectic system. This word, this adjective, eutectic, can be used in several different ways, and we usually hear it in the context of materials engineering or metallurgy. Whenever you're mixing two solid materials together to make this new mixed material, that's when you might talk about eutectics. So frequently when we talk about alloys, mixtures of two metals together, that's where eutectics come into play. Sometimes the pharmaceutical industry will talk about eutectics because they mix solid medicines together that don't react, but they mix together, and they want to make sure they know about the characteristics of that solid mixture. So what is a eutectic? It's a little bit complicated. I'll try to explain it. So you know how when you mix individual components together, like iron with carbon, you can add in a whole different amount of iron and carbon. You can mix 1% carbon with 99% iron. You can mix 5% carbon with 95% iron, etc. And those different compositions will have different material characteristics. It's really important to pay attention to that. And for example, let's talk about the melting point. If you had like 100% iron, it has a certain melting point. And then you gradually mix in a little bit of carbon so that it's 99% iron and 1% carbon. Well, the melting point will decrease a little bit. And then you add in 2% carbon and 98% iron. Well, the melting point will decrease again. By mixing in this other invading material, carbon, you're lowering the melting point. You're making it easier to liquefy. And the reason has to do with crystal structures. And I mean, you can imagine you've got this perfect crystalline lattice of iron atoms, all, equally spaced apart. And then you're throwing in this contaminant of carbon in there, and it breaks up the crystal lattice. It becomes easier to disrupt the whole thing, and heat will more easily liquefy your crystals. So that's why that works. And the eutectic point is where you've got this perfect combination of composition of carbon and iron, and this perfect temperature that is the lowest melting point that alloy could ever reach. Like you've got this exact temperature and exact carbon iron composition that you need that's producing the lowest melting point that you could see with that combination of materials. Like any other combination of iron and carbon will have a higher melting temperature, for example. And so the eutectic point might be interesting to pharmaceutical companies because they might want to avoid melting of their components. Like one component might melt at one temperature, another component might melt at another temperature. And when you mix them together, like who's to say what the mixture will melt at? And so if the pharmaceutical company knows the eutectic temperature of that mixture, well, they can just kind of avoid that temperature. And in metallurgy or metal forging and metal design, like the alloy designers might want to know the eutectic point because they want to get certain crystal structures, and they want to avoid certain components of their alloy melting. The cool thing about the eutectic point is that when you reach that temperature, all the components melt at once. They all liquefy all at once. You aren't like liquefying just the carbon or liquefying just the iron. And so that's kind of cool too. That is the word of the day, eutectic. I'm Pius Wong. I'm an engineer who has a consulting education company called Pios Labs, and it's also a studio that produces this podcast and the K-12 Engineering Education Podcast. Thanks for listening. If you'd like to support Pios Labs and myself, please do at www.patreon.com/Pios Labs, Pioslabs.